So in this session, students will be dealing with the pressure, its properties and how to measure the pressure, and we will see how the pressure in a liquid at rest depends on the depth or the gravity or what are the other factors on which it will depend. So let's start the session. Let's understand what is pressure. Now to understand this, I have given you a figure here where I have punched in 3 holes. Now if you see the holes, one hole I have punched it here, one is here, one is here. Now these holes are at a different depths from the surface. This is at this depth, this is furthermore, this is furthermore. And then you see what is the length that this fluid is going in the horizontal direction. It is coming like this, then it is going like this, then it has decreased. Now this interesting behavior will be explained later part of the lecture when we will be dealing with Bernoulli's principle. But what is the general behavior that you observe even in your real life is that the pressure is larger at greater depths. How do we say it about pressure? Because if the liquid is going a further longer distance, that means that velocity with which it is coming must be larger. So if the velocity with which it is coming is larger, that means that it must have been pushed with a larger force. Now larger force pushing is explained in terms of pressure. So this is a very vague idea of why the pressure should be greater here. Now we will see what exactly is pressure and how does it manifest itself. Now pressure is the fluids. Pressure is when the fluids exert force on the walls of their container and on the parts of the fluid. Now if you remember the figure that I showed you, that there was a container and then you had a molecules. Now all these molecules were in random motion. Now what happens when this molecule collides with this molecule also at some point collide, this will also collide here, 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 and so there are infinite number, very large number of molecules, they are all colliding with the walls. Now this collision, what happens in collision? If you consider one molecule and consider one wall like this, as it collides, it impacts it with a force, it pushes it with a force. Now this force that is acting on that particular area, it gives you the pressure. So whatever you measure from outside is actually this collision forces. The average of all these collision, all such collision acting on throughout the surface, the average effect of that is the pressure. Now they exert force on the walls and on the other parts of the fluids. Now how is pressure defined? Now the pressure is defined as is the force acting per unit area. Whatever is the force that is acting on a particular area, then for finding a pressure acting on that area, you divide the force by area. Now the pressure in the liquid is due to gravity. Now this what I showed you was for gases and it was quite evident here. How is the pressure coming in liquids? Now it is coming due to gravity and it increases with depth. The pressure within a liquid, it increases with depth. Now the pressure in a gas is primarily thermal. Now what happens? Why is the pressure in a gas is said to be primarily thermal? The reason is because this pressure is due to the collisions. Now why it is colliding? It's colliding because it has some motion. What is the source of that motion? Source of that motion is the temperature. It's because of temperature that all of the things are in random motion. They are exerting forces which is giving you the pressure. That's why it is called that it's primarily thermal. Pressure is constant in a laboratory size containers. Now why you may get a constant value of pressure when there may be molecules that are colliding all the time? It's because of the average value that you observe. A large number of molecules are colliding, it's the average value that you get which is a constant. Now the pressure in the liquid, it's due to gravity. Now we will see how this gravity is giving pressure in the liquid. Now a fluid in a container presses with an outward force against the wall of the container. Now what happens? This is the fluid. Now this fluid is pressing this wall. Now we consider this surface is on the wall of this wall, this surface that you see. On this portion we have taken 2 points. Now this fluid is exerting force on this portion, this fluid is exerting exactly on this portion and on this portion, on all of the portions that represent on the walls of the container. Now we know that the pressure is defined as the ratio of force to area. So what will be the value of that pressure? The pressure will be the force that the liquid exerts divided by the area. This is the area. If you consider this area A, then you divide by that area. That will be the pressure exerted by the liquid. Now the SI unit of pressure, it's Newton per meter square. You can see why. Force has a unit of Newton, area has a unit meter square. So it's Newton per meter square. Or to honor Pascal, the scientist, we have also considered this as the SI unit, that is Pascal. Now 1 Pascal is 1 Newton per meter square. Now let's understand more pressure. Now if you see here, this is a piston. This is like this. This is connected with a spring. Okay. Now what happens to a piston? I will draw a piston here. Suppose it's here like this. Now you connect a spring with this here. Now what will happen if you try to push it down? The spring will oppose, right? So suppose if you are applying a force of 5 Newton, when it is at rest, when it will come in a steady, when you apply 5 Newton, it will compress a bit and then it will come at rest. Now at that point what is happening? The spring is applying back a force of 5 Newton. Okay, this 5 Newton. So that means if you don't know whoever is applying the force from the top, if you know the compression in this, if you know the compression in the spring, I can tell that what was the force that was acting from outside. So that kind of arrangement is being used as a pressure measuring instrument, because what will happen? Now suppose if this is a cylinder like this piston will have a circular area, suppose its area is A, and then there is a spring here like this. If you put it in a liquid, if you put this whole system in a liquid, what will happen? The liquid will be exerting force on this, suppose F. Okay. Now if this is applying force F, it will compress this. What will be the compression when it will balance out? That will be the force equal to Kx. So now since we can measure X, we can measure the compression. So we will be able to know what was the force acting, because we can measure this, so I can tell what was the external force. Once I know force, what will the pressure? Pressure is force by area. This area is known to you. So you can calculate the pressure within a fluid at any point. Now this is the instrument that we will be using to explain things. Now what happens if you put this in a vacuum? Now in a vacuum there is no molecules. There is no molecules, there will be no force, there will be no force, there will be no pressure. That means there is no pressure, there won't be any compression. You will not measure anything. Now what happens? Here the fluid exerts force vector F on the piston with surface area A. If it is put in a fluid, suppose the fluid is exerting the force F. Now what will happen? This force will compress the spring. Now a force of a spring constant K is known. We know the force will be K into X, if X is the compression. Because the area will be known to you, you can find the pressure. Okay. Now let us see what happens when you put this pressure measuring device in fluid. And we are trying to actually see what is the pressure at different points in the fluids, how it is varying, how it is increasing, how it is decreasing. So we take a large number of instruments, put it in the fluid, and then we see the values of all of this. Now this is one, this is another large number, these three are almost at the same level but in different orientations like this. Now when you will put it, you will find that there is pressure everywhere in a fluid, not just at the bottom or the walls. It's not that you will only find the pressure here. It's not that the liquid is there and then you will feel the weight here and the pressure only here. It's present everywhere. How do you say it? Because I put that instrument and I found out that all of them were compressed. So there was some pressure present everywhere. Now the pressure at one point in the fluid is same whether you point the pressure measuring device up, down or sideways. This is again important. Now the pressure at a particular level, suppose if you consider this level, no matter how you put your instrument, it's not that if the fluid is pressing it from this side, or if the fluid is pressing it from this side, or the fluid is from pressing at this side. What I found was that the pressure was same in all of those three measuring instruments. So means it doesn't matter from which direction it is being pushed, the pressure that is being measured is same when it is at the same height. So the pressure doesn't depend on the orientation, it depends only on the depth. That I can say from this observation. And this third one, in a liquid what I found out that the pressure increased with depth below the surface. Means as I further go into the depth, I found out that it is being more compressed. It was very less compressed, you can see it's a bit more compressed, it's very compressed. You can see from the figure also. Okay. This was for the liquids. Let's see what happens for the gases. Now in the gases, there are an enormous number of collision of the gas molecules against the wall every second. What we do here is that we take this collision here. Now this is a molecule. What will happen? It will collide with this, it will exert force on it. Now this tiny force that is exerted, you find out the pressure for this. adding the pressure that is acting due to all such collisions that is happening will give you the average pressure, and that is what you get when you measure the pressure. So the pressure is due to the net force of the molecules colliding with the walls. So we have seen how the pressure is originating, how it is impacting, how do we measure pressure. The measurement is also very important. So we have seen the pressure and its behavior. Now atmospheric pressure, a very common term you have heard. Now what is this atmospheric pressure? Now atmospheric pressure is the pressure that we feel in the atmosphere. Now anywhere that you are standing or anywhere that you are sitting, you have here the column of air that is present above your head, going from here to the topmost level up till where the molecules are present. So how do you feel the pressure? The pressure is due to the weight of all such molecules. As I told you, the pressure is due to gravity. In the liquid, the pressure was there, right? Why the pressure was there? Pressure was due to the weight of the liquid. It's the weight of the liquid that you feel. That's why when you consider at this point, since what weight of the liquid will be present? Only this column of the liquid is present above this. So you will feel the weight of this liquid plus whatever air is present above. Okay. Now if you consider at this depth, what will happen? You will have this weight of the liquid total plus the air that is present. So you can see, because the weight of the liquid is increasing, the pressure that you felt was increasing with depth. Same thing happens in atmosphere. Now there are molecules that are present above. Consider a person who is standing here. He is feeling the weight of this whole column of the molecules that are present above his head like this. He is feeling the weight of this column of the liquid. So the pressure that everyone feels above his head is actually the weight of this by the area of your head. Now this is a constant throughout. Means if you will have a larger area, what will have? If you consider this column, you will have more weight of the liquid. This weight will increase. Suppose W dash. If you consider this column, it is W dash. But again the area has also increased. It has become A dash. So it increases in the same manner. W dash by A dash will be W by A. Where W is the weight of this, W dash is the weight of whole of this column. Now the density and pressure approach zero in outer space. We know the number of molecules that are present, it slowly fades out. The density keeps on decreasing, and then suddenly in the open space the density is zero. So there will be a finite pressure because of gravity, and density and pressure changes with increasing height. Now we have seen why the pressure is changing. Because if you consider a man that is standing here, what is the weight of that he is bearing on his head? It's only this column of the liquid. So he will experience less weight of the air molecules, so less pressure. Someone is here, he will experience this weight of the liquid. So again, more number of molecules, more weight, more pressure, but lesser than this man. So that is how the pressure is changing. So on the ground you will have maximum atmospheric pressure, it will decrease. And what will be the pressure at this point? Here it will be zero. Because in the space you have no molecules, so no weight above your head, so you don't feel any weight, no force, no pressure. Now what is the value of this standard atmospheric pressure? It is 101.3 thousand pascals. Sometimes written 1 into 10 to the power 5 Pascal, simplified manner. Now let us see a question based on pressure. Okay. Now a cubical block of side 2 cm is lying on a table. This is a table. Now you have a cubical block. Kept on the table like this. Okay. If the density of the material is given, it is 10,000 kg per meter cube. Find the pressure exerted by the block on the table. What will be the pressure exerted by the block on the table? Now what will be pressure? We know the formula for pressure is force by area. Now what is the area over which the force will act? It is this area. Because area of the block that is in contact with the table, on that area the weight is acting. Okay. And what is the weight? The weight is the weight of this cube. We know weight is a force. So that is the force present here. It is the weight of the cube by the area of this surface. Okay. So now as it is given that this is a cube and this is of side 2 cm. What is the area? Area of this surface will be 2 into 2. So that is 4 into 10 to the power 4 meter square. In terms of meter, it will be meter square. What is the weight? Weight will be the mass of this into gravity. Now what will be the mass of this cube? We know mass is volume into density. So V rho into G. What is its volume? We know volume will be 2 into 10 to the power minus 2, this many meters cube. Density is given as this rho into 10, this is the weight. So we have to find out the pressure. Let's put the values. So we have, this will become 8 into 10 to the power minus 6. Density is 10 into 10 to the power 3 into G is 10 by area is 4 into 10 to the power minus 4. Now if you solve this, what are the values? This whole thing is 10 to the power 5. This is 10 to the power minus 6, so it will become 10 to the power minus 1. Now this 4 will cancel this to give you 2. So you have 2 into 10 to the power minus 1, and when it goes in the numerator it becomes plus 4. So it's 2 into 10 to the power 3, that is 2000 with a unit Newton per meter square. So the pressure that is acting is 2000 Newton per meter square. The correct answer is B. So we have seen in our session what is pressure, how does the pressure depends on the factors, and how to measure pressure within a liquid. In the next session we will be dealing with how the pressure varies with the depth. So be tuned with Ask IITians for the next session.